And then this is discounted payback period method. So here the initial, when we are reading this project, initial outflow is 75,000. It is in bracket, right? When you you use Excel sheet, you have to type minus 75,000. I had to type minus 75,000. And this is an initial investment in year 0, right? And then after year 0, in first year, second year, third year, fourth year, and fifth year, question gives us here that you are making cash inflows of 30, 30, 25, 20, and 20. So this is 30,000, 30,000, 25,000, 20,000, and 20,000. These are from question, all these numbers, right? Now remember, this is discounted payback period. First method which we did today was payback method, right? It is the same method. Here we have to calculate payback period, and it would be in years, right? It is same as payback period method. But the only thing is, now we will consider the present value thing, right? This discount factor thing. Here you see in the question in the book, discount factor. I have not written it here, but I should have written here the column. This is discount factor. This is here, right? And this is here. And these are dynamically computed for this discount rate of 10%, right? So I did not just enter them here from book, right? So, and then how this one works, it told you net inflow is this much, question gives you, right? But it is like round numbers. I think somewhere in the question he says also, if you read the book, that these numbers are rounded off, right? But exact numbers, if you do the calculation, they come out to be these numbers. When I did calculation, it came out to be $27,272.73, and he just gave us a round number of 27,300. So sometimes the books show you just the what I call approximate numbers, and payback period is 3.3 in the book, and our answer is also actually 3.3, but our numbers in Excel sheet are exact numbers, right? So this is how you can do it. I will try to show it one last time here today. We still have few minutes. So discounted payback period, this is actually the model. If I can share that model with payback period. So this is the same question here, right? And everything is working same way. And if I click on this 3.3, you see here, this is the formula that I used. 3 plus absolute value of E4 divided by D5, right? So this is that one, right? So, and if I click here, you see that is the discount factor of 10%, which the book was saying. And if somebody comes and says, okay, Mahesh, discount is not 10%, it is 12%. I just change here. This is 1 divided by 1 plus 0.1 is 10%. If it is 12%, I will just make it 12 here, right? And click check mark here, right? And this is discount factor now for 12%. And then I have just to kind of redo these numbers. And it has automatically changed to 3.51 years, right? So this is dynamically changing. So the thing is, to summarize it, just I can, first of all, you should have a column which gives you years, right? Year 0, 1, 2, 3, 4, 5. Second column is that you have outflows and inflows. Here we invested money year 0, and then these are inflows in upcoming years. And this is the discount factor. And first one is always 1. Second one is dependent upon the rate of discount. If it is at 12%, these are the values. But if it is 10%, Let me go back to the original question. This is that value. Once you get it, you just drag it. These are now the discount factor for 10%. And then you will do what? B column into C column, B column into C column, right? So this is what you will do, B column into C column, right? And then I will change it back to 10% and change it here, drag it. This is now all these values. 30,000 into 0.91 gives you this number. Actually, it is not 0.91. If I increase the decimal places, then it is actually 0.909, which is becoming 91 actually. And if I increase it one more time, it is not 909, it is 9091. So in Excel, you have the luxury to go accurate to any decimal places. That's what I like about it. And then C column is calculated as per discount factor, and this is the formula for C column. I have talked here. It is according to 10%. And then after that, you get the fourth D column, for which the formula is this. And then you get the E column, which is just you are adding this number in the E column with the next number in the D column with this number. Right? So this is what it is. And eventually this is formula which gives us discounted payback period. So kind of when you learn a little bit, one column at a time, you process it and you get the values. And for this question, answer is 3.30 years. But as I changed from 10% to 12%, then required rate of return, then the answer changed from 3 to 3.51 years, right? So when required rate is more, then it takes more time to recover your investment, right? So I have generalized one thing, right? If in a way, we learned more than the book, because if from 10, payback period is 3.3. If cost go up to 12%, maybe you have to pay interest to bank more on the money that you have borrowed. You will take more time to recover your investment because you are paying more interest to the bank, right? And it would take you 3.51 years. And if cost goes from even 10 to 12, rather than 12, it goes to 15, maybe it takes you 4 years to recover your investment because you are paying more money to the bank as interest, right? So higher the cost or the required return, then higher the payback period would be. Even I can conclude with these calculations that I was doing, right? So this is exact calculation, but in the book, for example, this number, $27,272.73 was shown as 27,300 something. Let me switch back to the book here. Yeah, 27,300 in the book. So I mean, that is why sometime previously students were telling me, Mahesh, these numbers kind of don't make sense. And then I have to do this research to prove that, okay, these are not impossible numbers. And the easiest method where you don't have to pay money to purchase a software is to do it through Microsoft Excel sheet.
Thanks for watching. Keep on watching and learning.